Hi, this is Kieran from Team Chicken. We've built a development tool for Notch's new game, which we currently call the DevKit. In this video I'm going to demo a few of the features in DevKit, which you can download from 0x10c-devkit.com. So the demo we'll be putting together is a basic bootloader app. The user will be presented with a list of programs, and the selected program is loaded into memory on demand and executed. At the time of making this video, there aren't any external I/O or storage specs released for the DCPU, so to facilitate this kind of thing, the DevKit has web connectivity built into the emulated system, which we'll show off here too. There's no indication, of course, that the final game or product would have web connectivity, but it certainly opens up possibilities for experimentation in the meantime. DevKit is intended to be a comfortable tool for working with code, and to keep things easy to work with, code can be divided up into multiple files and projects. A solution is the top level part of a program and consists of projects, and you can think of projects as libraries of code that you might want to share or reuse between solutions. So I'll get started and create a solution called Loader Demo here, and add a couple of projects. The first is Loader, I guess, which will have the entry point and specific logic for the app. And the second we'll call Utilities, which will hold some common library functionality. Let's create some files, I guess, to plan out the different things we have to code up. First I'll create a main file to hold the loader code, and for utilities we'll create display to handle screen, output, input, of course, for input from the keyboard, and web will deal with the current means for getting external data into the system. So we'll create the display code first. Rather than watch me type, I've prepared some snippets to paste in here, so I'll explain as we go. The first thing I'll do though is just fill in these comments here, very handy, and we'll put a version number. Okay, so first, with most display libraries there needs to be some state to keep things like, there we are, the position of the cursor in video memory, the current output color, at least this high byte is used for that, and we've also got a cursor, which the high bit is set here to have it blinking, and it's a grey color, and the character in there is basically a full block, so you get a nice blinking block. That's just in case we want to change it. So there's a few methods. The first one is quite straightforward, clears the screen and resets the library. I've got this sort of simple standard here for displaying a bit of information about a method, and also return values, parameters and so on. So first of all, you can see that there's a nice ability to express constant values, literal values, with an expression, which just makes things a bit easier. This one's straightforward enough, of course, just loops through video memory, in fact starting at the end of memory, setting 0 into each location until it reaches the beginning of memory, and then resets the cursor to the first position, outputs the cursor block to show it, and then returns to the caller. So we've got a scroll routine here, and this isn't very optimized, no loops unrolled or anything like that, but it's fairly clear. Effectively scrolls the screen up by one line and clears the final line. So each memory location is set to 32 bytes, words I should say, later, which is the line below, until you get to the final line, and then it will, until it reaches the final memory location, it will clear it out. Now we've got some things which deal with the output of characters and lines and so on, and also this one here, which particularly helps with when dealing with keyboard input. So delete char here, this is where the cursor position and cursor come into play a bit more. Attempts to delete a character from the current line. So if you imagine you've got the cursor halfway through a line, the user's entering something, when you press delete, of course, it should move back to the back one space, unless you're at the beginning of the line, and then it should do nothing. So that effectively does that. It clears out the current location of the cursor, reduces it by 1, and then draws the cursor again, and it's as simple as that, really. So what we've got next is a string writing method, little function, which is actually quite straightforward because it delegates all of its work to a a separate method called display write char. So display write string here takes a parameter in I, just using a register there, which is a pointer to the string or the first word of the string. And there's a few nice features here, most of which are implemented by display write char. But simply this method loops through each character in the text in the string and calls display write char. So I should point out here, actually, there's a nice way I've come up with using the macros in DevKit. It's using Notch's own macro syntax, and it means that you can abstract away the calling convention of methods. It comes in pretty handy if you've got a separate project with some methods you want to call, and if you wanted to change the registers or the parameters later, you can do something like this. So rather than set I and then JSR display write string, you can simply put in your code display write string and then a parameter. And in fact, you could do that in the code, we'll see later, but you can say display write string and then a label referring to the data there, or indeed you can call it without parenthesis. So it looks a bit like an opcode. For example, you can do things like swap XY, and if you implemented something to swap it using the stack, it would seem like an opcode. It's quite neat. Okay, so the method that does all the work for display output is display write char. It's fairly straightforward, very much unoptimized, but nice and clear to read. So here it is. It takes a single character in A and writes a character to the screen. So there's a few bits of logic. If it's 13, then it's a new line. That's just ASCII standard. If it's greater than 1 to any 7, which is the upper end of ASCII printable characters, it will instead of writing it out or doing a new line, it will set the color. So that will effectively grab any of the color, or that high bit there is set for blink, and it will store it in the register which is used for the current color. C is in fact a cache of that, which is read at the beginning and written back at the end. So it will handle colors, it will handle new lines, it will handle regular characters, and if you get to the end of display memory, then it will call the scroll method, which I don't think we've got. Yes, we do have it here, of course we do, which will scroll it up. And that's pretty much it. With that, you can output all kinds of text, and it will automatically scroll, and you can just dump data. It's a nice, clean method. And that, in fact, is everything we've got for the display class. Just save that there. So let's move on to inputs. Input methods. Again, we'll give it a version, not strictly necessary. So to get started, there's a few directives again, just data used by input methods. There's the pointer here to the location of the next key in the circular keyboard buffer, and also, just to keep things easy, when we read a line from the keyboard, we're going to store it in a standard place, which is this input line buffer, and you can see we can reserve 32 words of space there. So get key, the simplest of all methods to do with the keyboard. I should say that with the High Nerd release, Notch gracefully released, there was a bit of a change in the keyboard code, I believe, versus what was expected before. The regular ASCII key codes are sent to the keyboard buffer, but also for a few virtual key codes, and there are only 4 at the moment. That's key up, key down, key left and key right. Some additional codes are put in the buffer. For now though, those are filtered out by this, but it's obviously pretty useful for determining which keys are down and putting together games and that kind of thing. So this one pretty much reads from the key location and repeats until there is a value that's not 0. Clears the location, that's so that the emulator or whatever's driving the buffer knows to write another one. Increments to the next location, and then applies a bit mask here so that if it were to go past 900F, for example, to 9010, then it would loop back round, take out the 1 and go back to the beginning of the buffer. Could be optimized again. We're using indirection here, so it will do a read and then an and then a write, but it's fairly neat. Okay, so getLine, I believe, is the only other method we've got here for input. It looks quite long, but really it's not too bad. It talks to the display functions we've got here to give the user feedback, But let's take a quick look. There's a return value here in I of the address of the input line buffer. That's in case we chose to do it a different way in the future and didn't use this fixed buffer. Perhaps we'd allocate it or something. Anyway, so we'll get a key repeatedly in a loop. If it's greater than 127, as I said, ASCII non-printable or some other key, we don't really care. We're going to loop round again, get another one. If it's 13, it's a new line, and so that will write the new line, in fact. So it will use the display write char, and that's the end of the loop. This reads until a new line, of course. If it's 8, then it's backspace. Got BS here. And if it's greater than 32, then it's something we don't, rather if it's less than 32, we can use that reverse notation there. Of course, there's no if less than, there's if greater than in reverse. So if it's less than 32, it's non-printable and we get another one. Other than that, it'll add it to the buffer, write it out to the screen, and go to the next location. So after calling this method, the user will have typed it on the screen, and it'll be stored in the input line buffer returned in I. So again, fairly straightforward. What we're going to look at next is the web functionality. Again, this is specific to DevKit, but provides a nice way of doing pretty out there things. For example, there's going to be floppy disks, I believe, in the game, and there'll be some kind of communications. And at the moment, most emulators, there's not really a way that I know of to get access to the outside world, but this just provides a route to that. And of course, in the future, if you write some code which uses some methods here to communicate, you can always drop in some replacement code, obviously separate files and projects, make that a bit more straightforward. First though, a quick word about web connectivity. There's a straightforward memory mapped I/O port A000 to download the contents of a particular URL. You just write each byte of the URL to that 16-bit wide port memory location, followed by a 0 to terminate it. The emulator will then request the contents of that and make it available to read back straight from that address again. So you'll issue the bytes that correspond to the URL and then a 0 and read back from that port until a certain response code is read, and it's FF00 to indicate that the request is done, and F000 in the case of an error. And it's as straightforward as that. So first of all, here's a function we'll paste in for now, web request URL, web request URL, and it takes the address of a URL string and sends each byte of that string to that port, followed by, including rather the 0 terminated one. So that does the first part of the request. Now the next one is show URL, and it handles issuing the request, which it offloads to that same method, and then it will loop through reading from that same port, bearing in mind X is set here to the port, and effectively for each one it's going to call display write char, so it will download from the URL and display it on the screen. There's some checks here, so if it's ASCII 10 it will ignore it, it's a line feed, only the 13, the new line, is useful for when you're displaying text. And if it's equal to FF00, as I said, that's the code that it's done, so it will jump to the done and return. The next one is the crux of the download work. It's web download. Fairly straightforward, but because we're downloading bytes at a time and using the upper byte here to determine when it's finished, we need to combine, but it's okay. Web download takes the address of a string to download from. It will save the resulting data to a starting address, and you can specify a limit of the number of words to put there, so you're not overwriting anything. So as before, it issues a web request URL call, which will start the download process, and then it will loop through, writing to location at J there. The parameter Z, which is the limit of words to fill, is used as a countdown counter, so when it reaches 0 we know that we're done, we're out of space, and it jumps to this little flush routine, and the flush routine there keeps reading from the memory location until it reaches the end. So in the case that you've downloaded a pretty large file, it'll stop overwriting memory and then download the rest of it. Other than that, it will grab a byte, it will detect the end condition and jump to the end of the method of the function if it's detected that condition. Other than that, it will grab a second byte because we know there'll always be a pair. We're downloading 16-bit data here. Shift that into the left, the high word of the register, and then add them together. So that's a little endian. It will then write the result to memory location at J, which is the starting address, which of course becomes each address in turn, and it keeps looping through until we're done. It's pretty much as simple as that. When it is done, it will jump back to the caller. So that one again, I've put together a nice little macro to help with that call, which rather than specifying the limit of words to fill, you can specify the URL, the buffer start, and the buffer end, which is the last address. And just to demonstrate the macro and expression parser there, the size is set to buffer end minus buffer start. So you can say something like web downloads my URL, and you want to download it starting at that address and finishing there. So rather than having to specify the length, or indeed you could use two labels: download area reserve 10 kilobytes, say, or rather I should say 10 kilowords. Download area end, and download area end. So you can see that's quite a nice way of doing that. Okay, so what we've built up here is a collection of useful methods: writing to the screen, reading from the keyboard, and also downloading a file from the web and displaying it optionally. What we need to do now is put all those together in some kind of useful method. So, bootloader example. Entry point. For now, the first file in the first project in the solution is compiled first, so execution will always start at offset 0, which is basically the top of the first file. First thing I usually like to do is get a bit of a border colour going. Let's say give a nice border colour. So this happens to be the word that's used again in that high nerd release from Notch to specify border colour. I think 9 is a bit of a light blue, something like that. Let's just give that a go. Yeah, so that's straightforward enough. Okay. So for a bootloader, what we'll want to do first is display a list of choices that the user can pick from in the form of a menu. So we're going to use web show URL for that. We need to grab the URL, which I've got prepared here. It's a Amazon S3 bucket, just for the purposes of testing. And then we'll call web show URL, having set I to the address. Let's give that a go. There we are, perfect. Downloaded, displayed on the screen. At this point, if I break, you can see it's just stuck in that infinite loop. After that, the user's going to want to select from the menu, and we're going to basically let them type a file name, which is the file that they're going to download and jump into next. There's the input getLine method, which will return in I a reference, a pointer rather, to the buffer. And we'll just try that. So the getLine method reads up to 31 characters, I believe, so you can go up to the end of the line. And you've got your backspace functionality, and the arrow keys are filtered, and generally does what it says. The next thing we want to do is combine that with the URL here and download the file, and then we'll look at putting it in the right part of memory and jump into the code. Now our immediate problem is that the request URL method here writes a single 0 terminated string. So what we actually want to do now is write just this part of the string and then append our own file name. So I'm going to request part URL, make a new function here that will do the same thing as the previous method but not write the trailing 0 terminator character. So effectively we're going to have it, let's say, always loop back to the beginning here, but then exit the loop if a terminated character is found. So web request URL part that loop. Right, so here's where it grabs the part of the string. If a is equal to 0, jump out the loop, request URL part done. And now let's fill that final gap and get that request sent. Right, first of all we want to send just a part of the URL. Obviously this is a bit redundant here, so it's a scope for optimization there. And we'll send out this part. We'll actually do it before we get the line from the user, because we're going to use the return value in I there to issue the final part of the request and do the final download. So issue request first part base URL. So we'll grab that and then web request part URL. Request part. So that will write this to the request URL buffer, and then it won't fire it off because it hasn't written that final 0, but we can do that here in the form of the download. Now we'll download I, which is going to contain the return value from the buffer, and we will go into just a free bit of memory, so let's call it, right, we're going to download to B000 onwards up until just before F000, and the reason is we need to have some code near the end of memory, which I'm going to put here, which will copy the code down to the beginning of memory and then jump into it, and we'll see that in a moment. So download the file. Here's a nice concept we'll go over, the actual bootloader code. Not incredibly straightforward, but quite simple to explain, so let's have a look. The bootloader code here is going to copy the downloaded code from B000 up until F000 down to 0000. Most code that's compiled isn't relative, doesn't use relative jumps, so it expects to be loaded starting at memory location 0. So that's why we're downloading it to this high location, and then this, as you can kind of see from here, it's copying data from I to J address, and it'll keep going until it reaches, let's say, F000. This code, incidentally, isn't going to run here because we're in the near the entry point. This is right near the beginning of memory. So this needs to be located elsewhere, therefore this code is going to be copied up, it needs to be relocatable, so hence this jump here, this is jumping to this line, we happen to know that this is 6 words and it's going to jump 6 words back. So this loop here isn't going to be run here, it's going to be run from the end of code. So here's a bit of code that will copy it up, copy bootloader to appropriate location. So it's the same deal copying using I and J. I kind of prefer those for index variables. So we're going to start there, and we're going to copy to F000, bootloader loop, and we're going to copy to contents of J. If let's see, I is equal to bootloader end. So we're going to start looking here at this line, and it's going to keep going until it reaches the end here. So if it's equal to the end, bootloader completed, copied, bootloader copied, and then this is a simple loop. Increment the source and the target. So you can kind of see how that's going to copy a load of code. And then jump to bootloader. So that will jump right to this code here as it's stored at location F000. Okay. I should have pointed out here, when it's finished copying, it jumps to the code that was loaded. That's fairly obvious. That's the big part where the loaded application starts. So in theory then, we're all complete. Let's give it a go, just a quick test. Okay, life. So we'll enter life here, and it's going to request the URL this plus life, which I've uploaded a suitable format of the game of life. Code safety, new plugin. Plugin system details to be announced soon, but effectively you can do things like hook to memory. Let's show off some of the debugging features. So you can see contents of address 0, which is associated with user code, has been overwritten. Break. So you can see here it's not detected any debug information for F000, so that's why it's giving us this, and it will keep warning us until we sort of say don't bother me anymore. So this is where it's copying the code down. Let's have a look at the status here, from this location to this location. So it's obviously downloaded the code and now it's just copying it. And in fact, another nice feature, if we turn off automatically follow and have a look at 0, we can sort of see it changing, here we are, the code and the bytes as they're copied to memory. So it's sort of a nice interactive disassembly view. Right, and if we hit run, it will finish copying and launch the game of life. Lovely. So that's kind of a nice end-to-end demo there. Let's see what else we can do. There's a variable CPU frequency here, so you can sort of slow it right down if you wanted. There's a little output here to show performance, or down to 1 kilohertz. I know Notch said that potentially you're going to find scrap CPUs that might be slightly higher frequency as well, so there's some options there. And it sort of starts looking a bit better around 5 megahertz, as you can see, which is very nice. I'll just restart it. Life. Oh, don't inform me again until I reopen. Yeah, fantastic. Very pretty. I wanted to show off the watch windows as well here. Say we wanted to learn some debugging. Say we wanted to look at the web download feature here. You can set a breakpoint on the first line here, and hit F5 to run, and we get a break, and we can step through as you've seen already. Also worth pointing out the watches window here. You could monitor value of A, let's see, X, which is where we're writing to, not very useful, but also you could take a look at that. You can do other things as well. If you had a method that passed parameters on the stack, you could do things like this. You can combine in very strange ways as well. PC minus, let's say, B plus O times 2. Fairly useless, but you can see how you can build up expressions that are going to be very useful in code. Yeah. Run it. Yeah, same thing. Obviously the set of debugging tools is intended to expand over time as well. So we're going to get a stack window, memory window as well, hopefully in the coming releases. Right, well hopefully you've got a better idea of how DevKit works and you're thinking up some ideas for cool things to do. There's a new release, this one here, out just now, 1.2 beta, however you say it, which has many new features and improvements, coming very soon, as well as the plugin API, allowing people to create virtual peripherals and devices. Planned after that is the modular language API. We've got .10c files, which is the built-in language. But the modular language API will mean other high-level languages will be supported in DevKit as people make plugins for it. So thanks for watching, everyone. I hope you find the prospect of the game and coding for it as exciting as we do. You can find a copy of this solution here available to download on the website and linked in the video description. Heartfelt thanks to everyone who's provided feedback so far for DevKit. We very much welcome suggestions and bug reports through the website, and I'll see you soon.